All right. So, hello and welcome everyone. Welcome back. So, I welcome all of you to this amazing platform of Tutee Learning. Today, we're going to discuss about another very important topic, that is 3D geometry, right? So, in today's session, we're going to be starting with discussion on the 3D geometry, and with the upcoming lectures, we will try to see about the different concepts and topics that is basically a part of your syllabus, especially in your 3D geometry portion. Okay. So today we are going to start with the very first lecture on 3D-dimensional geometry. So in this particular lecture, we are going to discuss about all the basic formula that you need to understand in order to solve questions, especially of this particular topic for JEE Mains and Advanced. Okay. Now please note that whatever we are discussing over here will be relevant only to the JEE Mains and Advanced syllabus. Okay. So whatever we will discuss over here is only limited to that particular examination. Also, apart from JEE Mains and Advanced examination, if you are someone who is preparing for other competitive engineering service examination like WBJEE examination or BITSAT examination, you can also take advantages of these particular lectures. Okay, so for that, if you're new to this particular platform, please like, share and subscribe the channel, because this particular channel is going to help you a lot in preparing for your upcoming JEE Mains and Advanced portion. Okay. Now, as you can see that not only we are basically projecting videos on mathematics, but along with maths, there are videos on chemistry, physics that is basically been put up on this particular platform. Apart from this, we also have our another platform called Tutee Learning NEET, where you can prepare for your NEET examination and you can prepare the biology concepts. Okay. So with that particular thing said, let's start with the basic idea of vector 3D geometry, right? Now, please note that this particular chapter is going to be a very simple chapter if and only if given condition is that you have to have a basic idea of vectors. Okay. Now, that basic idea of vectors, if you want to study vectors from the beginning, we have already discussed vectors in very brief, in detail, all those topics. Okay. So, please go back to the channel description, or maybe you can check out the channel and check out the playlist that we have covered on vectors. With that particular thing said, let's start with three-dimensional geometry. All right. So, as you have already studied in coordinate geometry in your class 11th, that if you have like the coordinates, so let us consider the coordinates as x and y axis are the two coordinates. Now, along with this, if I add one more coordinate to denote the three-dimensional plane, if I add one more coordinate, so these are mutually perpendicular three-dimensional axes which denotes the coordinate frame, right? So as you can see over here, this is a three-dimensional axis, right, which denotes the real world, right? Now, very important to understand that any point in this particular three-dimensional axis will be identified by the set of a tuple x comma y comma z, where x, y, z are three individual numbers, right? So this x, y, z will denote any point, any random point on this particular three-dimensional plane. So in this particular three-dimensional coordinate system, any point will be given as a ordered pair of three numbers, right? I hope this is clear, right? Now let's start with the very basic things, that is starting with the distance formula, right? Now it is obviously very simple, and as you have already seen in coordinate geometry, that if I give you 2 points, let us say P1, let us say the 2 points are P and Q, and the corresponding coordinate is given as follows. So let me write this particular coordinate of P as x1, y1 and z1. Then the basic understanding of distance formula says that the distance between this particular point P and Q will be given as square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square, right? So I let me write it properly so that you can have no confusion. So the square root term comes over here, z2 minus z1 whole square. Okay, so this is a result for finding the distance between 2 points in three-dimensional plane. So if I have 2 points whose coordinates are given, then I can easily find out the distance between the 2 points using this particular formula. Now this is a very simple formula to give us a distance, right? So we are starting with a very basic thing so that you have understanding of everything, right? Now similar to this particular result that we've already seen in our coordinate geometry, one more result is going to be the same, that is going to be section formula, right? So if you recall, the section formula for internal division and external division in coordinate geometry for two-dimensional plane, the same thing will be applied in three-dimensional plane as well, just with one more addition of another coordinate system, right? So that is very important to understand. So let us say that I have my points as P, which is again given as x1, y1 and z1. Okay, and I have another point Q, which is given as x2, y2 and z2. Let us say the points are given something like this, and I have this particular straight line, right? Now if I want to find out any point which is internally dividing this particular line in the ratio m is to n. So if I need to find out the internal division, first of all, so if I need to find out the internal division, okay, so if I need to find out the internal division of this particular coordinate of r, then the formula is very simple that we have already seen. The formula is as follows. So it will be m times of x2 plus n times of x1 divided by m plus n, m times of y2 plus n times of y1 divided by m plus n, and m times of z2 plus n times of z1 divided by m plus n. So this is how we will obtain the coordinates of internal division of any point which is dividing the ratio, which is dividing this particular line segment PQ in the ratio m is to n. Please note that this particular formula applies only for internal division. Now you already seen that for external division case, you have already seen that for external division case, the plus sign just changed with a negative sign over here, right? So I am putting a circle over here so as to denote that whenever you are doing the external internal division, so the sign will come accordingly. Okay, so please take a note of this particular thing. So whenever you are doing the internal division, it is positive, and when you are doing the external division, it is going to be negative. So please take a note of this, and you can apply to them in any types of formulation. Okay. Now similar over here, if I need to find out the midpoint, then the midpoint will be obtained simply as just by putting m and n equals to 1. So I will obtain the coordinates of the midpoints, right? So in the similar manner, if I need to find out, let us say I have a triangle in a three-dimensional space. I have a triangle in a three-dimensional space given as A, B and C, with A as x1, y1, z1, B as x2, y2, z2 and C as x3, y3 and z3. So in order to find the centroid, if I need to find out the centroid of this particular triangle, then I can easily do that by taking x1 plus x2 plus x3 by 3. Similarly, the y coordinate will be given as y1 plus y2 by y3 by 3, and then the z coordinate will be given as z1 plus z2 plus z3 by 3. Okay, so this is how we can obtain the coordinate of centroid of any triangle. Right. So these are the very basic things that we need to remember while we are going to discuss with the basics of three-dimensional geometry. Right. Now let us try to understand that how do we actually represent any line on a three-dimensional plane, or before that, let's try to again discuss about the concept of position vector. Okay. So till this particular point, I hope this is clear to all of you. I hope this part is clear to all of you till this point. Cut and polish. Hello. Start questions. Well, cut and polish. This is first of all, we need to discuss the theory. Okay. So let us first of all discuss the theory beginning. Okay, and with that, once we build up the concepts, we are definitely going to solve questions. Okay, it is not that I'm only going to discuss question as of the chapter is concerned. Okay, so if you want to solve questions, you can join us in the later half of this series of lectures. Okay, maybe some few days later. Okay, so for question, you can join us on some other lectures. Okay, on future lectures. Okay, so please subscribe to the channel as well as hit the bell icon so that whenever we are live, you get a notification of that. Okay, is that part clear to all of you? Okay, so let's now discuss about, first of all, let's try to discuss about the concept of position vector again in three-dimensional plane. So we have already seen, yes, I am from IIT, yes. So let us quickly discuss about the position vector thing. Okay, so let me quickly discuss and go on with the position vector thing, which we already studied in the previous topic of vectors, right? So let us say that I have the coordinate axis as follows: x, y, and z over here, and let us try to plot any point x comma y comma z. Now we have already seen that if I join the point with the origin and I try to make a vector over here, then this will denote my position vector. So this is going to denote the position vector of point P. Alright, so this is the position vector of point P, and we have seen that this particular vector can be given as x I cap plus y j cap plus z k cap, right? This is how we denote any position vector, right? Now along with that, we already seen some other important things, that is basically relating to the angle of orientation of this position vector with respect to the x, y, and z axis. So let's try to say that this particular line, this position vector line, makes an angle alpha with the x-axis, beta with the y-axis, and gamma with the z-axis as follows, right? So if I say that alpha, beta, gamma be the angles made by this particular line OA, OP with the x, y, and z axis respectively, then we have already seen and studied about that then cosine of alpha, cosine of beta, and cosine of gamma is going to represent, this particular thing is going to represent the direction cosine. Okay, so we have already seen that this particular thing is going to represent what is known as the direction cosine. Okay, if you have any question in this particular part, direction cosine, you can refer to my previous lectures on vector algebra, right? Because is it possible to crack JEE in 3 months? Yes, it is definitely possible to crack JEE in 3 months. Okay, only thing that you have to do is basically, first of all, try to identify the high priority or high weightage chapters. Okay, so please try to work on the high weightage chapters, especially if you are right in this particular portion, you have no zero preparation. I would rather say that for mathematics, you can go with vectors and 3D geometry. Okay, because that is a very easy part and very high scoring part, right? And after you're done with the vectors and 3D geometry, I would suggest you to study the matrix and determinant part. Okay, so your strategy would be basically to focus on the high weightage portions, okay, especially in maths, physics, and chemistry. Try to focus more on the chemistry part, okay, because chemistry you can easily score high by putting less effort. Okay, just you have to memorize some things, and with that you can definitely go on. Can you suggest me the high weights? See, as I already said that for mathematics, vectors and 3D geometry will be a very high weightage topic, because you don't have to push much of an effort. Rather, you can score high marks from this particular topic. Okay, so this particular chapter is a very high weightage topic. Okay, so I would rather suggest study the vector and 3D geometry portion, and then you can, for maths, you can study the integration part. If you have a basic knowledge of calculus like differential equation, differential calculus, then you can start with integration. Okay, because integration is also going to be a very high weightage topic. Okay, also differential equation, if you have studied basic of integration, then differential equation would be very easy. Differential equation and area under the curve would be also very important. Okay, apart from that, if you are also going to invest some more time, then I would also say that please prepare matrix and determinant and probability. Okay, try to prepare probability and this particular topics. Okay, because and also the preparation or probability might be very subjective to person, because I have seen some students saying that probability is a very difficult portion, right? Rather, if you look at the probability part, like the Bayes theorem or the total probability theorem, those particular parts are slightly easier, right? So on the slightly easier side. So I would suggest you to prepare those particular topics, especially for the JEE Mains concerned, okay? And don't worry much about the first attempt, okay? Try to give your best for the first attempt, yet please make your mind clear that since you have a lesser preparation, you should always focus on the second attempt. Is that clear, Vikas? Is that part clear to you, Vikas? All right, so let's now move forward, and we have already seen this particular thing of direction cosine in our previous discussion of vectors, right? Now we've already seen that these are called the direction cosines, and we have represented them as L, M and N, which denotes the direction cosine. And we have already seen a very important formulation based on this, that is L square plus M square plus N square will be equals to 1. Right, so we have already seen this kind of formulation. So in today's class, we will be solving some questions based on this. And also one more important thing to note over here is that we have already also discussed about another concept of direction ratios, right? So we have already discussed about another concept of direction ratio, where if I say direction ratios are nothing but they are just a vector denoting that particular direction, okay, or the individual components of the I cap, j cap and k cap, right, of any given vector. So I can say that a, b, c are my direction vectors for direction ratios for a given line. That means that a by l should be equal to b by m should be equal to c by n is equals to some constant, let us say lambda. So okay, this particular part is equal to some constant, and that is equals to lambda. So this is what our direction ratios should follow. Okay, fairly simple, right? So I can also derive another relation between any direction ratio and direction cosine, saying that let us say I have any vector, which is given something like this. Now you already know that the individual components of I cap, j cap and k cap of these particular vectors is nothing but they denotes the direction ratios, right? So over here, if I say direction ratio or dr, then it will be denoted by a, b, c, right? But if I need to find out the direction cosine, the only thing I need to do is basically try to make this a unit vector. Try to make this v vector a unit vector by dividing it with the magnitude of that particular vector. So if I do that, I will obtain my relation as a upon square root of a square plus b square plus c square I cap plus b upon square root of a square plus b square plus c square j cap, right, and plus c upon square root of a square plus b square plus c square k cap, right? So this will actually denote the direction cosines, right? So direction cosine are the components of this ijk for the unit vector, okay? So it is very important to note that the direction cosine are the components of the unit vector, whereas the direction ratios are the components of the general vector. Prashant, sir, will you solve questions in this session? Yes, we will definitely solve question, but first of all, let's try to understand the theory part. Okay, I will definitely take up questions in this particular session only. Okay, we'll try to see how we can use this particular idea of direction ratios and direction cosines to solve JEE Mains and advanced problems. Okay, so I will give you an example of JEE Mains problem, and then we will try to also generalize that particular idea as well. Right? All right. So I hope this is clear to all of you. Now, so what you understand by this particular part is that direction ratios and direction cosines, they actually imply a very important thing, that is they are basically nothing but as a components of the vectors, right? So if I have the direction ratios or direction cosine, I can obtain my vector of that particular line, right? So if I have, let us say I have two lines and whose direction ratios or maybe direction cosines I know of them, right? So I can easily find the angle between the lines from their direction ratios as well. So let us say, so let us try to give an example of that. So let us say I have two lines in three-dimensional plane like this over here. So let us say this is my line number 1, and let us say this is my line number 2. Okay. So let us say this is line number 1 and line number 2, and this is my angle between the line. Let us say the line number 1 has the direction ratios as A1, B1 and C1, and the line number 2 has my direction ratios A2, B2 and C2. Okay, so if I have this formulation, I can easily find out the angle between the vectors as, or angle between this line as, cosine of theta. Now I can consider these direction ratios to be the components of the vector. So I can just find the dot product, that will be A1 A2 divided plus B1 B2 plus C1 C2 plus C1 C2 over here, and then divided by the magnitude of the individual lines, that is A1 square B1 square plus C1 square and square root of that, and another square root of A2 square plus B2 square plus C2 square, right? So this is what will give me the result for the angle between two lines whose direction ratios are given to me. So if I know the direction ratio of the given two lines, I can easily find out the angle between the lines from their result of direction ratios. I hope this is clear to all of you. Is this part clear? Is this part clear to all of you? So based on this, let's try to solve some questions that has been asked previously in our JEE Mains examination. Okay, so I will give an example of question based on this. So let's try to solve some question in order to get an understanding of the type of problems that you can face from this particular portion. Okay, so it's quite an important portion, and if you look at the JEE Mains previous year problems, you will find some general problems also being asked on this particular topic. Okay, but more generally the questions are generally of the topic of equation of straight line in planes, or maybe the planes concept. Okay, but still there are questions which you can which are there based on the direction ratios and direction cosine. Hence, it is very important to also have an understanding of this, right? Is that part clear to all of you? Is that clear? Please let me know in the live chat. Is this part clear to all of you? Please let me know in the live chat. All right. So, if this part is clear, let me give you a problem where I can show you that how you can use this particular concept to solve questions in the examination. So this is our question we have with us. Let us say, now this is a very interesting problem, and these kinds of problems are the most favorite kinds of problems, especially for your JEE Mains examination. Okay, so if you look at this problem over here, first and foremost thing that you can understand is that it is said that two straight lines are given whose direction cosines are given by the following relation, that is L plus M minus N equals to 0. So I can use this particular relation, that is L plus M minus N is equal to 0, and another relation L square plus N square plus CNL is equal to 0, and it is said that these two straight lines are parallel to each other. So if I have this condition, then I have to find out what is the positive value of C. That is what the question denotes, right? So how do I do that? So what you observe is that if I have this set of equations for consisting of L and M, I will obtain two set of values for L, M and N each, right? So I will have two sets of values. So if I try to represent the given equation that I know, so L plus M is equal to N, I can write like this. Now similarly, another hidden equation to solve these three equations is that I cannot solve these three unknowns with two equations. So the equation that I already know is that L square plus M square plus N square is equal to 1. Now, if I have this following result, what I can do is that first and foremost thing is that try to substitute N as L plus M in my first relation. Okay, so if I do that, I'll obtain L square plus N square, L square plus M square, this is M, right? This M over here. Okay, so L square plus M square. Now in place of N, I will put CL into L plus N, which is equals to 0. So if I evaluate this, I will get 3 plus C L square plus CLM plus M square is equal to 0. Now another equation I have. Now first of all, what you try to understand from here is that this is an equation in L and M. Now if I try to change this particular part such that saying that what I know that these two lines, whatever the straight lines is having the direction ratios or direction cosine L, M and N, they're given as these two lines are parallel lines. So whenever two lines are parallel, what I can denote is that the line, if I have this line as a vector, then the parallel line will have some lambda times of a vector, right? So any multiple time, any scalar multiple of that particular vector will give me a parallel vector. So that basically being said, what I can substitute over here is that I can substitute that since the lines are parallel, they will share the same direction ratios. So I can represent the L in terms of some lambda times of N or M, right? So let me do that over here. Since they are parallel, since these lines are parallel, what I can do is that I can substitute L as some lambda times of N. Alright, so if I have this particular part over here and I will substitute over here, then I will get a quadratic in M over here. Alright, so this is my equation. Now if I simplify this part, I will have an equation in lambda. So that will be lambda square plus 3 plus c plus lambda c plus 1, and then m square will be taken out as common. Now m square cannot be 0, because if m is equal to 0, we will lose our part, then L will be also equal to 0, and that will be a coinciding line. However, we need parallel line. Therefore over here my value of m should not be equal to 0. My value of m should not be equal to 0. Therefore, this particular part should be equal to 0. So if this particular part is equal to 0, and since I have these lines are parallel, then I will obtain only one value of lambda. Only one value of lambda, and that will be only possible when I have equal roots, right? So that will be only possible when I have equal root, and the condition for the equal root is that we try to make the discriminant of this particular quadratic equation to be 0. So if I do that, I can carry out, and that particular thing will again become a quadratic in C, which will be something like this. And this I can solve it easily, and this will give me the result of C. This will give me the result of C as 6 and minus 2. So I will obtain the value of C as follows, as 6 and minus 2. Now, if I put the value of C as 6 and minus 2, and let me check that for which value am I getting, or we have to look for that for which particular case of C will give me the following condition of lambda, right? Now, this is basically said they are parallel, so I should have lambda to be positive. So if I put C is equal to 6, I see that I get my lambda to be a positive lambda. Whereas if I put C is equal to minus 2, I don't get positive lambda. So I have to put value of C is equal to 6 in order to get a parallel lines. Therefore, the final answer to this positive value of C is going to be 6. That is also basically mentioned in the problem, right? So the positive value of C will be equals to 6. So with this, option A will be the correct answer. Is this part clear to all of you? Benzoic acid, yes, it is clear. Sir, is every hope lost? I have prepared decently but forgot a lot. See, benzoic acid, the only suggestion that I can give to you right now, I know you must be having a lot of tension because your exam is very near about, right? And you have a lot of things to cram up, and also have to keep those things in mind, and also have to prepare a lot, right? Practice a lot of mock tests, right? So one more suggestion I can give is that please try to make short notes, okay? Because short notes is going to be very, very crucial and helpful, especially the day before the examination. So the day before the examination, you cannot revise everything, right? So the only thing that you can revise is basically the short notes, okay? So try to make the short notes, try to make the main part of the topics or whatever you studied in that particular chapter in form of small question like formulas or theorems. Okay, so please try to write this particular part down, and please write the main important formula and the how you are basically getting the formula, just to have a small amount of recapitulation, right? So all that particular part, if you put that up in the short notes, I think it will help you a lot in doing or revising for your JEE Mains and Advanced examination. Okay, so that will help you a lot, especially if you are forgetting things. Okay, so keep on doing that particular part so that you get that better help. Okay, and also when you're doing that particular chapter, or once you are solving practice question, just go through your short notes once again. It will help you revise that particular part. Okay, so keep it doing regularly, and automatically things will definitely be embedded in your mind. Okay, so with this part, I would like to conclude the session over here, and thank you for your lovely attention, and we will see you again in our next discussion, where we're going to discuss about the straight lines or the equation of straight lines in three-dimensional geometry. Okay, or in 3D, how do we represent any straight lines? So that is what will be the next topics, and with that, in the upcoming classes we are going to discuss about planes. So this basically forms the basic guidelines of the three-dimensional geometry, and we will definitely solve more questions in the upcoming lectures to understand the concepts in a deeper manner. Okay, so this is all what you need to remember, and with this part, thank you for attending this session, and I hope to see you up soon in the next class. All right, and if you're into this particular platform, please like, share, and subscribe this particular platform, and also hit the bell icon so that whenever we are live on this platform, you definitely get a notification and you get a direct chance to study and ask your question live one-on-one on this particular platform. So thank you, and I wish you all the best.